Welcome to The Explainer. Today we're going to talk about something that strikes fear into the hearts of so many software engineers, the system design interview. Yeah, this quote really hits the nail on the head. This whole interview, it's not about finding some magical, perfect solution. Nope. It's really about showing how you think. It's about your problem-solving process, how you weigh different options and trade-offs, all while the clock is ticking. And when you're faced with this huge, open-ended problem, it's so easy to just freeze up, right? To feel totally lost. The secret, though, the key, is having a solid framework, a kind of mental map that you can pull out every single time to guide you through the conversation. So that's exactly what we're going to do today. First, we'll look at the challenge itself. Then, we'll build out that step-by-step framework I mentioned. After that, we'll stock up your architectural toolbox with all the core concepts. Then we'll cover how to master the conversation, and finally, we'll pull it all together. All right, let's get into it. The very first thing we have to do is kind of reframe what this interview is all about. Seriously, it's not a test. There isn't a secret correct answer hidden somewhere. What the interviewer really wants to see is how you tackle a big, messy problem. They want to hear you talk through the trade-offs and, work with them to sketch out a blueprint for a solution that could actually work. Okay, so how do you navigate that conversation? Well, you need a map. And what's great is that we can take all the best advice from experts and boil it down into a really clear 5-step framework. Just think of this as your roadmap for that whole 45-minute journey. And here's that map. It's a simple, logical progression. You start by clarifying and scoping the problem. Then you sketch out a high-level design. From there, you deep dive into the most important parts. Next, you look for potential bottlenecks. And finally, you review and wrap everything up. See? It just makes sense. You're building your solution from the ground up, one logical step at a time. Now, this first step, it is absolutely the most critical one. Whatever you do, don't just jump straight into designing. You gotta start by listening, by asking questions to take this huge, vague problem and shrink it down. So instead of design YouTube, you get them to agree on something like, okay, so what we're building here is a video upload and viewing service, maybe for, say, 10 million users. Boom. Right there, you've defined your scope and set the stage for everything else. Now, before we get to the other steps, we need to make sure we have the right tools for the job. We need to stock our toolbox. So, let's talk about that architectural toolbox. What are the essential concepts you absolutely need to know? Think of these as the building blocks, the fundamental pieces you'll use to have those really important conversations about trade-offs and to make smart design choices. First up in the toolbox, scaling. Sooner or later, your system's going to get more traffic. The big question is, what do? Do you make your one server bigger and more powerful? That's vertical scaling, or scaling up. Or do you just add more machines to share the load? That's horizontal scaling, or scaling out. You see, scaling up is easier to manage, but you'll essentially hit a physical limit. And if that one big server goes down, well, everything goes down. Scaling out is way more fault tolerant, but it's also a lot more complex to manage. And this brings us to a really, really crucial insight for building big, scalable systems. You have to get good at identifying the things that don't need to happen immediately, right? Not every single thing a user does requires an instant response that they have to wait for. And that is where something called a message queue becomes your best friend. Seriously, just think of it like a to-do list for your system. It's a place where you can just drop off tasks that aren't super urgent, things like sending a confirmation email or transcoding a video. This lets your main system give the user an instant response without getting all bogged down by those slower background jobs. This comparison makes it super clear. Look at this synchronous way on the left. The user places an order, and they have to sit there and wait while the payment is processed and while the confirmation email is sent. Only then do they get a response. But look at the asynchronous way. The user places the order, the system processes the payment, and bam, they get an immediate response. That whole send the email task, it just gets tossed into the message queue to be handled separately. The difference in user experience is just night and day. All right, another big one. This is a question you're almost guaranteed to face. Which database should you use? And look, there is no magic one-size-fits-all answer here. It always depends on what exactly you're trying to build. And a lot of the time, the choice comes down to this classic matchup: relational or SQL versus non-relational or no SQL. So SQL databases are all about structure and consistency. They're perfect when you need every single transaction to be absolutely perfect, like in a banking app. On the other hand, you've got no SQL databases. They're all about flexibility and scaling out to a massive degree. They're what you'd probably reach for if you were building something like a social media feed. Underpinning this whole database decision is something called the CAP theorem. It's a really famous concept in distributed systems. And what it basically says is this: you have three things you want: consistency, availability, and partition tolerance. But you can only have two of them at the same time. You can't have all three. So a huge part of the interview is explaining which two you're going to prioritize for your system, and more importantly, why. Okay, so you've got your framework, you've got your toolbox filled with these core concepts. But that's only half the battle. Having all this technical knowledge is great, but how you communicate your ideas, well, that's just as important as the ideas themselves. Here's the really crucial takeaway for this section. You have to treat this interview like a collaborative design session. Your interviewer isn't an adversary. Think of them as your first teammate on this project. So get up at the whiteboard, draw your diagrams, and talk through everything. State your assumptions out loud. Discuss why you're choosing A over B. You're basically taking them on a guided tour of your brain, showing them how you think. All right, let's wrap this all up. Let's talk about how to bring all these pieces together. What's the final mindset you need to have to really deliver a great performance? You have to remember this. The goal is not to produce some perfect final diagram on the whiteboard. The final design is actually less important than the journey you took to get there. It's all about the trade-offs you talked about, the questions you asked, and how you explained your reasoning every step of the way. And here is a pro tip, something that really separates the good candidates from the great ones. The most impressive people, they plan for failure. They actively talk about what happens when things inevitably break. When you start discussing things like monitoring and logging and how the system will handle failures, you're sending a massive signal that you have the mindset of a seasoned senior engineer. So I'll leave you with this final thought. A truly great design, it isn't just about being scalable or reliable right now. It's about being maintainable for the future. So, as you're designing, ask yourself this: how would you build a system that not only works, but can also be understood and improved by the next engineer who comes along?